Today we're going to solve systems of equations with three variables. We're going to be using a combination of substitution and elimination. Our first example, we have three equations, and as you can see, each equation has one fewer variable, and so we already have one variable solved for. We already know that z is going to be equal to 3. Well, when we already know one, and the second equation has 2y is equal to z, you can see this, and we can actually substitute this z equals 3 into the second equation. So we will substitute this directly in right here. So that gives us 2y minus 3 equals 7. Since z is 3, we just replace that. And since we have the second equation reduced to one variable, now we can solve for y by adding 3 to both sides. And then to solve for y, we'll just divide by 2 and then have y is equal to 5. Well, now we know 2 out of our 3 variables, which means we can then take both of those variables and substitute it into the first equation. So we're going to substitute z equals 3 and y equals 5 into the first equation to solve for x, which will give us 3x plus 5 plus 2 times 3 to show the 2 times z equals 8. And begin solving for x by multiplying the 2 and the 3. Don't add the 5 plus the 2, remember PEMDAS, which will give us 3x plus 11 equals 8. And to solve for x, we will subtract 11 and then divide by 3. And so we have our first variable. We have our last variable. So since we have all three and we have a system of equations, our answer is not an ordered pair. We have 3 numbers. It's going to be an ordered triple. And so we would write the answer with the variables alphabetically. So our answer is -1, 5, and 3. All right, second example, we have a very similar example to our first one. So we're going to begin by taking our z equals 2 and substitute it up into the second equation, and that way we can solve for y. So we'll replace z equals 2 into the second equation and begin the process of solving for y. So we'll subtract the 2, and then we'll divide by 2, and so our second variable is 8. Now, since we have 2 variables, that means we can take the x and the y and substitute it into the top equation, and then we'll be able to solve for x. So we have replaced our y with 8 and our z with 2, and we can solve, begin by adding, and we'll have x plus 20, and subtract the 20 on both sides. And then x is going to be -5. And so we will arrange our 3 variables as an ordered triple, and this will be our answer. Okay, our last example is a little bit more involved, and as you can see, we have 3 variables in 3 equations. So I'm going to begin by labeling my equations as equation 1, equation 2, and equation 3, and that will help me keep things straight and in order. So what we do with this example is that we're going to pick one equation to use as the one that we multiply by so we can solve by elimination. And the second equation is the more simple of the 3, so I'm going to choose that one. So we're also going to choose a variable to eliminate. We want to eliminate the same variable twice. So I'm going to begin by eliminating the variable z, and I'm going to choose an equation to multiply by, when that will be my second one. So in order to eliminate z from the top equation, we're going to have to multiply equation 2 by -3. So I'm going to write down my first equation, 2x plus y plus 3z equals 9. And then I'm going to write down my second equation multiplied by -3. And we chose -3, so if we add the two together, then the z will be eliminated, like so. So if we add those together, there's going to be a 0 in the z position. And so what we have done is made a new equation that we can use to add to another one. So we want to eliminate z again. I'm going to keep my second equation as the one that I multiply by. So I'm going to begin by writing down my third equation. And then I'm going to write down the second equation after it's been multiplied by -2. And I picked -2 because that will cause me to eliminate z. So this is the second equation multiplied by -2. And I'm going to add those together. And that has given me another equation. So what I can do with these two equations, if you see the two equations that we made only have x's and y's, and what we can do is eliminate a variable. And what I see is that my y's both have a 7. So if I multiply one of my equations by -1, then I'll be able to add those together and solve for x. So I'm going to multiply one of the equations by -1 and add these two. So I picked the one on the left. I multiplied it by -1. It looks like I'm subtracting it. When I end up distributing that negative, we would end up adding them. So we have a -6 plus a -x, so that's -5. We're eliminating the y, and then it's going to be equal to -5. So when we solve for x, we get x is equal to 1. So we still have two more variables to go. Since I know that x is 1, I'm going to take that x equals 1 and substitute it into one of my two new equations that I made by elimination. So here's my two new equations. Sometimes it helps to draw a box around them or something to distinguish them. If I substitute x into 1 in one of these, I can solve for y, and the easier one to use is going to be the top one that I've got listed there. So I'm going to have -1 plus 7y equals -15, and now I can solve for y, so I'm going to add my -1, so I'll end up with 7y equals -14, and then I can divide by 7 for -2. So I have x equals 1 and y equals -2. So I need to solve for z now, and it does not really matter which one of the three equations I use. I'm going to pick the second one because there's no coefficient in front of my z. And so I'm picking the second one. You can try another one and see if we get the same answer. So I've got x minus 2y plus z equals 8. That's the one I'm going to choose. I'm going to substitute in. And I will end up with 1 plus 4 plus z equals 8. Add the 1 and 4 together. Subtract the 5. And I get z equals 3. And then I'm going to write my answer as an ordered triple, like so. And that ends solving systems of equations with three variables.